Thank you. Sorry, I had it off. First off, my opinions are my own. They're not my employer's. So about me, my name is Jason Edgecombe. I'm a Linux administrator in the College of Engineering at UNC Charlotte. Open source work in my personal time. I'm the BuildMont admin for the OpenFS project, and I've also contributed documentation. We have various websites up here, including work and a couple of my personal sites, including my GitHub. So let me give you a breakdown of the college. We have 5 departments. We have most of the major engineering disciplines: civil, mechanical, electrical. We also have systems engineering and engineering technology. For those who don't know, the systems engineering is more of an engineering management. It's touted as the alternative to the MBA. And engineering technology is more of applied. So this is your technician level. To put it in perspective, an electrical engineer would design your pacemaker. An electrical engineering technician would fix your television. That's they're more of applied stuff. And in addition to the major departments, we also have various research centers. One of the bigger ones that's been in the news recently is the EPIC Center, the Electrical Power and Infrastructure Center. Big deal, got a whole new building out of it. So yay, EPIC. So here are some stats. We have roughly 3,300 students who majored in the College of Engineering in fall 2014. 2,700 undergrads, 600 grads. All told, we have a little over 200 faculty and staff that we have to support. Over 4,000 login accounts as of last month. And we have a 10-person IT team. So these are the full-timers, plus various student interns who are actually students who we employ, and that's part of their training, their education. We pay them, and they help us, and in turn, we help train them for their degree. We have 2 Linux admins for the college, and we still manage to support everything. So we have 2 managed platforms. Of course, we have Windows. We can't avoid it. And we have about 1,200 workstations for Windows. Various supporting servers under Windows as well. Pardon me. For Mosaic Linux, and these are the titles of our platforms. We have these branded platforms. The managed platform is called Mosaic, and Mosaic Windows is a managed platform. The managed Windows platform, Mosaic Linux, is our managed Linux platform. So on the Linux side, we have about 41 production servers, mixture of bare metal and VM, 65 Linux desktops. These are split amongst office and research labs. And all told, we have about 141 Linux machines between all told workstations, VMs, servers, development servers, all that. Now, I mentioned that we have our Mosaic platform. We also have various standalone machines. So these are semi-managed. They're not running the standard corporate style desktop that we like to support. But this is how researchers work, is they can't be constrained by things like actual best practices in IT, because that slows them down. And no matter what we do, it never seems to be fast enough. They want to be able to do it themselves. So just so you know, the engineering college is one college or one part of the University of North Carolina at Charlotte. So we actually have multiple distinct IT groups. Each of the colleges have their own IT group, and then we have a central group that provides support for the entire campus, in addition to some of the colleges or departments that don't have what we call distributed IT. So the things that we don't maintain in the College of Engineering are the campus network. It's a network switch. We typically don't mess with it. We don't have to maintain the websites. Central IT does that. They set us up with Drupal, and some of our staff and faculty just edit Drupal pages. We have a research cluster that's run by main campus IT. That's called the University Research Cluster. They handle the big compute, multi-node type of compute jobs. So we also don't handle Moodle or the campus ERP, which we use. It's called Banner. So what we do support, or what I support day to day, is the Mosaic Linux platform. And on that platform, we have over 50 commercial and open source software suites. I mean suites, not just programs. I mean, Synopsys or Cadence. I mean, these are, each of these have like dozens of programs underneath them. So that's a pretty big footprint. Currently, we're running Red Hat Enterprise Linux 5. We run the client flavor on the workstations and the client-facing servers where they log in and run big compute jobs. And then we have the server component or flavor that we run on our backend servers that only the IT staff log into. So one of the critical things we've been very adamant about is only IT staff have root or sudo access. So this goes back to the managed versus unmanaged, and that's one of the reasons that people don't like to, might not like our managed platform, is because they can't install stuff that they want, or at least they don't have the control that they want. And one of the big things that stands out is the Linux team is actually responsible for the network storage for the entire college. So we run OpenFS as our network storage, and we have those spread across many servers. So the Linux team is actually supporting the storage that even the Windows team uses. So everybody uses the Linux team. So key philosophies that we have: we strive for a high level of customer service. Automation is a way of life. Now, we don't typically use imaging. Now, the Windows team tends to use a little bit more of that just for some server backups, but both teams use scripted installations. So our Windows team is doing, they're doing scripted install, and then they have scripts after the install that start installing applications. On Linux, we're using Kickstart from Red Hat, and then we have post-installation scripts that fire up. They're firing up running CF Engine, which then manages the machines and that kind of thing. So not much imaging going around, like I said. We store everything on the network, or at least as much as possible. We store our scripts, we have roaming profiles, and home directories. One of our key philosophies is workstations and servers are disposable. And by that, I mean I can walk into someone's office, and so long as they're not storing data on the local drive, which some do, but if they're not, then I could take that workstation, throw it out the window, put another one in, pop in the boot disk, wait a while, and they're back up and running. Or they can just, the machine's down, walk to the next office, walk outside, walk into a computer lab, start working. Their files are there, they didn't lose anything. Something that's really kind of interesting, even on our file servers, we treat them as kind of disposable, which seems a bit weird. The primary disk is disposable. We do not like to store persistent data on the primary system disk. So what that allows me to do is if a server is active, if a server is just so messed up that I can't get it to boot, or I can't get something to work, all right, boot it off the network, run the installer, clobber the system disk. Comes back up, it's good. And then, in fact, since the install doesn't touch the secondary, tertiary, and extra disks, I actually didn't lose any user data. So it's been this weird scenario where I've actually rebuilt a production, it's been down, but a production file server, it's acting up, it's got user data on it, rebuild it, 30 minutes later, it's back up and working. I didn't have to back up, I didn't have to restore. So that's a pretty cool thing, I think. So we do offer remote access to all of our constituents, all the way from freshmen all the way up to researchers and grad students and PhD students. So currently we have 10 servers. These are some Dell rack mount servers. They have roughly about 8 cores each, 16 threads, some a little less, like 64 gigs, but the best ones have 96 gigs of RAM. For our future, we're going to 2 servers, and those have 8 cores, 64 threads, and 256 gigabytes of RAM. So we offer both remote and graphical SSH access, and that's actually more of a remote desktop style environment. And what that does is that offers us kind of a virtual lab type scenario. Now, right now, today, we use FreeNX for the graphical desktop, and that's available all over the world, globally accessible SSH. But we're looking to go behind the VPN at some point pretty soon because our security guys don't like that, and I get lots and lots of failed demand emails every day, as you can imagine. And FreeNX is no longer really supported or maintained, so we're looking at going at XRDP as our remote graphical solution. And interesting thing is we don't have very many Linux labs. So this is actually used on-site and off-site. So if people need to use Linux, they actually go to a Windows machine in a lab, they fire up RDP or they fire up the NX client, and then they connect to a graphical desktop and they do all their computing. And that works fairly well as long as they don't have to plug in hardware. So the current automation, like I said, is a Kickstart automated installation. We're actually running masterless CF engine with AFS to distribute the files. We use quite a few scripts, a mixture of Bash, Perl, and Python. So CF engine is the coordinator that kind of runs on every machine. It copies down files, does things, and then it will install the cron jobs or which run programs or directly run programs, which will help get the machine into the desired state. We use Git for our version control system and for moving code changes between the different environments, between dev, test, and prod. So that's mainly just, each developer has their own repo. Once they're done, they commit, they push to testing, and then from testing, we can push to production. And we can take different machines and can move them between the different environments fairly easily. It's just a flag file that we have to touch. For RPMs and packages, we use just folders of RPMs sitting in AFS. These are actually distinct and separated from Git. I'd like to improve that a little bit in the future, but we can release those independently. For our future platform, we're going to go to Red Hat 7. And we're looking to use Red Hat Satellite, which brings us with Puppet, which I'm looking forward to. That also includes Catello, Foreman, and Pulp. Those are all rolled into Satellite. This has the advantage that we have these lifecycle environments now. So we can use our Puppet code and our packages actually roll out as a unit. They're no longer managed independently, and we can keep them together so we have the same snapshot. And that's going to be looking forward to saying we have a nice lifecycle environment that goes from dev to test to prod and keep those coordinated. The content views are used to synchronize the Puppet modules and the RPMs, which is nice. And one of our key goals is to reduce the dependency on a shared file system for our management tools. So right now we have everything running out of AFS. Everything is a script that just reads from AFS, and AFS is accessible on every machine. And essentially that is the message bus and the distribution mechanism for all of our scripts and all of our machines. So we're looking to decouple that so we can have the option of moving to something else. So ongoing challenges and how we've responded to them. So we all have the usual suspects, budget and staff time. So the way we tend to deal with that is we automate and we streamline things. And that's worked fairly well so far. For example, it does not hurt me in the least if someone says, hey, I want another workstation. Hey, I want another cookie cutter web server. I could go spin up another one of our production web servers. No big deal. I mean, the hard part is it takes longer for me to go coordinate the DNS changes and the firewall changes with central IT than it does to actually get the server up and running. Where it comes into where it requires more time is when you start diverging. You need configuration changes or something that's drastically different from one of our current builds. So other things we do is we engage stakeholders to set the priorities because, well, all right, if you can't have everything, what do you need? What do you give up? Just making sure that they understand that and pushing it back onto the faculty because there's like, hey, I want everything. I'm like, no. Decide what you really need. I can't be the one, and the IT team cannot be the ones to say, oh, this professor is more important, this professor's research project is more important than this professor's. No, that's a business case. That's a business level decision that we need to push back on them. So we're making some progress with that. Interns for some of the stuff. I've been pleasantly surprised by some of the interns I've hired. I have one of them in the audience over here. Thank you, Daniel. And some of them, some of my interns have been so good, I've actually given them admin rights. Yeah, they've had not just sudo, but full admin, like domain level admin type rights in Linux. Read everything. You mistype a key and hundreds of machines go down, kind of thing. Other challenges we've had quite a good bit of growth, 12% growth in the last 5 years. So, you hear on the news, there's a big push about STEM, science. We're on the receiving end of that. Everyone wants to be an engineer. Yay! Please send us your kids. We'll take good care of them. And the way we deal with that is we automate. We try to streamline, set priorities, like I said before. Something that's very interesting, kind of a bit quixotic, and people don't quite understand, is we actually tend to have a bimodal user population. Or if you look at the standard bell curve, we're just really, really stretched flat. So we tend to have both the early adopters and the conservatives. So on the same department, or possibly in the same professor, it's like, all right, I want program X to be the latest and greatest. Why don't you have the latest and greatest program X? Why aren't you running the latest Linux kernel? And then on the same token is, wait, we can't upgrade this program because the chip fabricator will not take anything newer. I had a professor, I kept basically emailing him and screaming at him saying, look, you need to get off this program. The vendor's already given us the, we're discontinuing it. This is your last license file, last license file will issue for this older version. We're really serious this time. And I can't blame the guy because he was relying on third-party libraries that no one had updated yet. So I think they finally got it upgraded. So it's just very interesting and both rewarding about trying to deal with this. You've got latest and greatest and conservative. It's just interesting. So other ongoing challenges, users want root or sudo access, especially the electrical engineers. They're trying to do hardware development without root is kind of a buzzkill, and I get that. So the way we address that is we do this through better customer service. It's like, hey, I need this. Why it becomes we make it so easy for the professor, look, we'll handle that for you. We will upgrade the applications for you. Why should you spend your time managing or administering a Linux system instead of doing research or instead of doing teaching? And they usually come around. We make the managed offering almost irresistible. And what tends to happen is we get new professors come in, and the first thing they ask for is, why can't I have my own box? Why can't I have I want root, I want sudo, I want to install applications. And it takes them about 6 months or a year, and they finally kind of calm down. It's like, oh, well, wait, I don't have to worry about this. It's taken care of. Let me go do other stuff. Let me go work on getting tenure. But we do have people who don't, for which the managed model does not work well. And for those people, we set up standalone machines. So those are the semi-managed or kind of the unmanaged machines where the grad student or the professor is the one who's actually doing the administration. And we will help them, but we have a different hybrid team for that, which I'll get into. So in order to support both the central people, the managed desktops, and the semi-managed desktops with the distributed user model, the laptops, that kind of thing, first off, people can choose which one they want to do. We have professors who actually have one of each in their office. And that granted, one of those machines is, fairly new, within 3 or 4 years old, and the other is usually, 5 or 6 years old. So it's not, unless they're buying the machine, they're not getting, 2 new machines. But we have a hybrid team. We have a hybrid team that does kind of the laptop standard support, and then we also have the managed team, which supports the centrally managed stuff. And it's actually worked fairly well. So, as I said before, we have, the mixture of the bimodal user populations. So we have some also divergent application requirements. So you have this application X wants this version of the library, or one of the more interesting things is, for example, console has to install a version of MATLAB as a dependency. And I actually had to, at one point, we installed console and then a slightly older version of MATLAB inside the same folder just for console. And then we had the normal MATLAB installation in a separate folder for people who just wanted to use MATLAB. So we have, this is when we do the network applications or network installation. So we typically have about 2 or 3 different ways to install applications. We have RPMs for open source. If we compile it or install it from a vendor, we're going to install it on to like opt-coe, which is a symlink into an AFS network shared folder. Every application gets its own folder, and we try to install the applications into that folder along with dependencies. We have things called wrapper scripts, which set LD library path just for that application, so we're not polluting the entire namespace. Works out pretty well. We can't always fix this. Things like glibc, that's been a big deal as far as, hey, your glibc is too old, you're on Red Hat 5. We already have some applications that can no longer upgrade, like MATLAB. I can't upgrade MATLAB until I go to a new version of Red Hat. But that's not the only thing that's had things like glibc dependencies that are too old or too new. So I'm hoping that Docker may be able to help with this, but we haven't gotten there yet. One of the things that's kind of interesting is, in many businesses you have the corporate network and it's trusted and you know what's on there. We don't. I call it a semi-trusted network. It's like the difference between having your server somewhere in Charlotte versus having your server somewhere, out of the country. So first off, I assume the attackers are already inside the firewall or even inside the machines. So I try to lock down the machines. I have grad students or undergrads who are trying to write a C code program, and they may do a scanf loop, and all of a sudden you have a program in an infinite loop. So through either not necessarily malicious intent but accidental intent, we have to monitor this. So we have to keep things running even though the users are trying to bring things down, sometimes intentionally. I run fail-to-ban on all my workstations, all my servers. And something I'm really try to be careful about is wary of applications that have little or no security. As an example, we have IPython. Well, it uses 0MQ. 0MQ has no bloody security. If you run IPython and you're on the same machine, you can, and if you know how, you can go and read someone else's session. Thankfully, IPython can put a little bit of security in there on top of 0MQ, but we run into this mindset that, oh, you're one user and one machine. No, that doesn't fly. I'm sorry, the taxpayers, we would just be laughed out if he said, oh, hey, I can't say that give every researcher a 256 gigabyte of RAM machine. That's just not cost effective. So what I've noticed is kind of an assumption, even though we're back in the kind of the Unix time sharing days, Linux does that very well. And what I find is there's this kind of movement away from that in the community saying, oh, hey, oh no, you're on a laptop, you're root. You know, we try, you're on the machine, we trust you. I'm like, no, I can't do that. That violates my core assumptions. So that's sometimes I'm working against the vendors or the distros, or they're working against me. I guess that's another way to put it. Challenges yet to be conquered. Research, it's always a big deal. It's becoming more of a big deal, especially with just trying to supplement, get more research dollars in. We have special requirements that sometimes can't be handled by the managed offering. And those are both from a security aspect and a technical aspect. So for example, okay, yeah, this application needs a newer version of the library that we don't have on Red Hat 7 or we don't have on Red Hat 5. So technically we can't deal with you, or security-wise, this thing is so hairy that we can't let anyone else log into the machine, or this software has to be limited to, it can't be used by people who are non-US citizens, stuff like that. And we've gotten around a good chunk of that, but it's becoming more and more hairy. And what's really frustrating is that you think, okay, just beef up the security, but that's not good enough, because each research grant or each funding institution has slightly different permutations of security requirements. So you can't necessarily satisfy both or multiple grants they don't have a common set that you can say, all right, if I do A, B, and C, I will be able to satisfy all these grants. No, they don't mesh. They aren't compatible. So you end up with these forking these one-offs. Okay, this is for research grant A, this is for research grant B, because they have such divergent requirements. And believe it or not, federal agencies have drastically different requirements. Even not DOD, just, some of the, the less sensitive stuff, but they still they don't mesh. It's weird. So another big thing is storage. We want more of it. We want it for free. That's it. I'm not kidding when I say I have a faculty member and his research team, they treat 3 terabyte hard drives like floppy disks. I mean, they have a little USB hard drive dock, 2 or 3 USB hard drive docks connect to the workstations. They start swapping them out. They have, a stack of them sitting on their desk. Security, again, kind of the, trying to keep the managed platform together and consistent without letting everything bifurcate and fork, because avoiding the forks is how we are effective and how we leverage the automation and how we can manage all these machines. The overhead of management is not a function of how many machines we're managing. It's an overhead of the function of how many different configurations we're managing. I can go fire up, 100 web servers. If they're all the same cookie cutter config, no problem. If they're all different, one's running a LAMP stack, the other's running Tomcat, and the other's running, Python, that's when things start getting crazy. And as far as security goes, the core values of a university are openness. So we sometimes are forced to be the software police and the security police, and we sometimes have belligerent users, sometimes very well-funded users that they don't want to be under the constraints of these tighter security, which we're bound by either contract or regulation or conditions of the grant or software licenses. So we're both trying to serve the user and trying to coerce them to play nice at the same time. I guess it's been compared to being a parent. Other things, are we going to consolidate, in order to be more efficient? What services can we shift to central IT? What needs to remain in-house? These types of things. So the future is uncertain. For example, we're looking to replace our network file system, which is why we're trying to, decouple all of our management infrastructure from the network file system. We're looking to replace our user directory, which we don't currently have one. We have a password file that's distributed and then pushed out into a Berkeley database. You know what NSSDB is, that's what we're using. And our backup system is in sore need of updating. I was in the speaker's lounge yesterday and I said, oh, I'm going and rotating the tapes. And even though I can do it remotely, he's like, and one of the other speakers in there is like, you're still using tapes? I'm like, yeah. They're not even managed automatically. Other things we're looking at doing, Docker. Hey, I'm really excited that, hey, maybe I'll be able to have these multiple environments and encapsulate the environment for every application so that we can have that newer glibc or that newer version of X library that needs to be done. Cloud, Amazon, private, whatever, how can we spin them up? How can I have computing on demand? Wonderful stuff. It's exciting. And one of my personal favorites is continuous delivery, trying to be better, faster. How can we automate this, do automated tests, make sure things are working? This is one of my personal goals, just to try to see, are we getting better? I mean, can we measure that? So that's the end of the canned talk. So the other half of this is questions, discussions. Yes. Okay, so how do we manage communication between us and the users? We have several things. First off, personal contact. I've been in people's offices. They call me directly. They email me directly. I try to avoid the adoption problem where people always come to me. I keep telling them, go contact the help desk. I'm on vacation, go contact the help desk. But no, seriously, we'll send out broadcast emails through listservs. We actually have a custom application in the system tray on Windows and Linux. It's called the message of the day. And when we have an important message that doesn't necessarily go over email, because people, they just have a filter that delete. Oh, it came from Mosaic. Delete it. they don't read the emails. So we have a program that comes up, and the message comes up in their face, which then they just promptly click go away. But we have multiple ways. We tell them, we email them, we have the message pop up. We'll go and talk to them if we need to. We try to be very approachable. And one of the things I try to do is I try to maintain a relationship with some of the researchers and some of my Linux power users to see, what are you doing? What are your pain points? What do you need? And by doing that and by engaging with our users, it's the concierge service model. Let me help you. What do you need? And by maintaining that relationship, I figure out, I get, these little tidbits of information. Oh, you're doing this. Okay, well, here, let me show you how to do this better. And in just having the conversation, I find out that there's this thing coming out of left field, and now I actually see it before it hits me. Or sometimes that's when it's coming out of left field, and that's when it hits me. But at least it's like, all right, we didn't know about this, but we need to address this. So at least I found out about it. And we get things at all stages of the pipeline. Obviously, we want to see things ahead of the curve. We want to plan for it because, we're booked 6 months out, essentially, or 3 months out for projects, installing applications. Obviously, users want things now. Oh my God, and I can't exactly blame them. I mean, some of it is, yeah, I was too busy. Others is, yeah, I was told yesterday that I'm teaching this class in the fall and I need the software installed. I have pity for those people. I have pity for those for those. But yeah, just trying to maintain a relationship with my users. Yes, we use a ticketing system. We have our own ticketing system separate from central IT. Central IT is actually going to, they're looking at a new ticketing system. So when that discussion comes around again, we're going to look to see how we might integrate with that. Currently, the ticketing system migration discussion is on hold because we're right in the middle of migrating everybody's email to Gmail. So that's the big priority. Just everything else, just let it wait. Yes. Do we do asset management? Yes. We have our own asset management called DeviceDB, and that actually does some asset management, but what it's really meant for is more of a configuration management database kind of ish. So our managed assets have to be in DeviceDB. In fact, for Windows, a Windows machine will not build unless it's in the asset and unless it's in DeviceDB. As far as non-managed assets, those get to be a little trickier. The university manages, they have assets, inventory control, tags, and tracks anything over $5,000 purchase price. But yeah, so that doesn't cover most of the PCs and servers. So we're having to actually do our own tracking at some level. And I'll be honest, a good chunk of it probably goes under the radar. But as far as the managed platform, it's a prerequisite for having actually to build a platform that it is in the database. Yes. How do we keep the people with the money makers from saying replace everything with Windows? Because some of my money makers demand Linux. That's I am. Now, I'm not to say that I'm immune to the Windows everywhere problem. In fact, the reason we don't have a dedicated publicly accessible Linux lab is because there's not enough space. It's not that there's not enough money, there's not enough physical space. There's I like to call it the space wars going on. We need a new building. People are fighting over research space and grad student offices. And there's a big push of, hey, we're making students they're required to bring a laptop. Why don't they have that? Why do we need to provide a workstation in a lab that we have to replace every 4 or 5 years when they've got a laptop and they can run their software there? So we've also got that challenge. It does, and it brings up licensing issues for students. So, some licensing is all over the map. There's, you'd think there'd be some standardization. No, You're correct. If we had an open source advisor in every university and every university adopted one open source project, we would have a lot of good quality or better quality software. I don't just, seeing what sometimes comes out of student coders and whatnot, I'll say better, not necessarily good. Yes. No, not for authentication. Okay, so the question is, do we use Unix password files for authentication? No, we actually use Kerberos. The Unix password file is simply distributed as kind of the user directory. Here's your account, here's a list of accounts, here's a list of home directories, here's a list of UIDs and GIDs. That's how we use the password file and distribute it. Does that answer your question? Is the backend managed, is the directory managed by central IT? There is a central IT Active Directory which is managed by them. However, we don't authenticate against that currently. We like to, we're looking at that, but that causes some interesting issues of, hey, we're not mounting home directories off the central storage, which is actually going to Dropbox now. So that's kind of up in the air. But no, we're actually managing our own Kerberos realm that we use for authentication. I believe you in the back. Did you have your hand up first? Oh, you. What are we So what are we looking at to replace OpenFS? That's a good question. And that's oh, you're welcome. So what are we looking at to replace OpenFS? That's a very good question. And to your point, as you said, nothing quite matches the user experience of OpenFS, the strong authentication and authorization model. I mean, quite literally, if one of my workstations is compromised, if you have root on one of my workstations, that doesn't mean jack for OpenFS. You are an unauthenticated, you are the anonymous user. So, unless the only way you compromise AFS from a workstation perspective is you have to go snoop someone's credentials or grab their tickets or tokens off the machine and then use that to authenticate. And even then, you've only got the authentication or the authorization for that person. So unless you happen to get in the admin's machine, you're not, or one of something running, got some privileged access, one of our privileged machines, you're not going to get very far. When I'm looking at the different spaces, if you look at an FSv3, the acronym, the joke is, no freaking security, and it scares me. It's no wonder our security guys just don't understand OpenFS. They think, oh my God, this, how can you do this? They must think that we're in kind of an NFS model where the client is enforcing the security. No, the server is enforcing the security. Things I'm looking to replace it. My personal front runner is Gluster, although in that regard, I'm looking at running it as just like a NAS head. I would actually be mounting NFS v4 and then maybe some Samba shares. My boss has thrown out just buying a NetApp appliance. Whatever we do seems to be a step back or a step down from the user experience and the feature set of OpenFS. But that seems to be where we're headed, just because everything else integrates with SMB or NFS v4, and it's weird. The programs don't tend to support this model of, hey, you can lose access to your files, if your login runs out. We don't kick you out, you just magically lose access to your files. You can't write anymore. And we're still looking. I'll let you know, but it's probably going to be something SMB or NFS v4 based. That's about where I am there. You had a question? Okay, so are we moving home to Dropbox? Campus IT is looking at Dropbox as the storage, essentially, yeah, the home directory for central IT and mainly actually, no, was it the faculty and staff, or was it just the students? That's right, it's only faculty, staff, and student workers. So students have had this, pittance of 200 meg of a network drive, which is terrible, and they're just saying, you know what, that we're not even gonna pretend, we're just gonna get rid of it. So they're saying, look, everybody's got laptops, everybody's got thumb drives, why fight it? And how can we manage that? When I can't, the permutations are endless, saying, okay, where are you mounting your USB drive? How am I going to do that? I can't suddenly manage profiles are not possible. I mean, it's, I feel that we're going to almost end up keeping a network file system just for ensuring the level of service that we're currently providing. So that's a big challenge that we're currently wrestling with now. We don't have the answer. And what's interesting is that it's not entirely clear what central IT is doing. So since we're not even sure what they're doing, we can't really decide yet until we know where they're going, because where their direction will determine what we do. Yes. Correct. Gmail, G Drive, Google. Yeah, Google Drive and Microsoft SkyDrive or OneDrive, they're great. I mean, they work well. You can store files to them. They just don't, they're not a POSIX file system. They're not something I can use as a home directory. Everyone's like, oh, hey, it's storage. I'm like, no, if I can't mount it and have it as a POSIX-ish file system, it's useless, at least as a home directory. So, do we go to just, local disposable home directories? That seems like it just seems like almost like a disservice. And to answer to correct you, everybody's going to Gmail. It's not, in fact, faculty staff are going first. My personal account's already, well, my work email's already on Gmail. Since I'm IT, I'm a early adopter, and the whole college is moving on July 5th. The rest of the faculty staff will be done by the end of summer, and shortly thereafter, we'll get the students migrated over as well. That's, as I understand, the plan is. Yes. Cool. Oh, you're welcome. You're welcome. Yeah, you're right. You're right. The having the local solid state drive typically is more performant than the network file storage or network appliance or anything you throw at it. If you have to go over the network, the latency and the I/O is just cut an order of magnitude. I get that. But the advantage, the selling point you give them is, hey, we've got backups. You have a level of service. You don't have to worry about copying the files to another machine. And we do have complaints that AFS is slow because it's a network file system. It's not going to be fast as local. I'm not sure. People don't really tell us what they want sometimes. Okay, so you've set it up so users can self-serve for a whitelisted list of like Yum repos, that kind of thing. Sure. No, that's a good comment. That works well, but that also assumes the one user, one machine model. So, and for the most part, if something is out in Apple or some really quick RPM, it's like, hey, it's fine. And that usually isn't a big deal. Hey, I need an RPM. It's already here. Here, go install it. Fine, looks good. Roll it out, that afternoon or 2 days. Actually, for most of our applications, even some of the vendor stuff, we can get it turned around. You know, if I've got a student worker who's trained and up to speed, they can turn around in 2 or 3 days. So it's not a challenge of, all right, I need this application. We can usually upgrade those. Where it gets to is, all right, this application has these, it's troubleshooting the application of, it doesn't want to install, it needs this version of the library. But if the dependencies are already there, then it's usually pretty good. And if someone says, hey, I want, like I said, you know, I want something from Apple, fine, yep, done. Sure, that sounds pretty good. I'd still have to get the, you know, they wouldn't work for our compute servers and the remote servers that everyone uses, but it's a good suggestion. Thank you. Yes. What software do we use for backups? I wish we used RSync. No. The software we use for backup is the built-in AFS backup suite. That includes a command called backup and butsy. And it's also a series of, and that actually is just the, you know, all that, basically it's doing a bunch of volume dumps directly to tape, and there's a set of custom scripts, I think we got originally from Transarc or some other university, that manages kind of the process of, oh, hey, let's go fire this up. So what happens is there's a scheduled job on all the file servers which does a snapshot at midnight, which is actually a very cool feature because we have every user's account has a backup snapshot from midnight of the previous night. So that cuts that down on a lot of backup requests of, oh my God, I deleted my file. So, but that snapshot is then sent to tape at, you know, sometime during the morning or possibly late afternoon. And we just have some custom scripts that handle that. And they'll go through and they're marginally intelligent about, oh, hey, I need to go fetch the next backup tape. But I literally spent yesterday, our hardware admin is, we're currently between hardware admins who would usually handle this, but I've been cross-trained on that momentarily. And I literally have to spend every Friday, because full backups occur on the weekends, going in and swapping, making sure the tapes are in, the right tapes are loaded with, you know, MDMTX command, and then labeling the tapes to make sure that everything's good. In a previous life, I used Amanda. That was awesome. But the challenge is that since AFS is not exposed as a traditional file system, you can't just say, oh, I've got this local folder, I'm going to share it out with via AFS. The structure of AFS storage is actually opaque, so you have to use the built-in AFS tools in order to do a backup. And not many backup tools are integrated with that. Your options are either you do it yourself with a custom tool. There have been some various attempts at trying to add AFS support to one of the open source tools, or you go with the single commercial vendor that cost an arm and a leg. Yes, did that answer your question? Good. So what's your question or comment? Yeah. Yeah, there are some tools like Backup PC that have kind of AFS support bolted on, but it's maybe a little kludgy. Definitely nothing mainstream. Yes. Do we test restores? It's been a while since we actually did to do a full restore, but we get a steady stream of, hey, can you restore this file from 3 months ago? So from that regard, we get testing done that way. The backups work. In fact, we had a request, someone who had left the university and then come back. They had been gone long enough that their files were actually deleted off the file servers. but they wanted to restore their previous file contents from like 2 or 3 years ago. No, it was 2 years ago, just barely within the tape window. So we actually had to go and restore that from the, the end of semester dumps. Yeah, it's not our job. They were placated. Yep. Why does it take so long? I can install. Why do these things take so long? I can install an application on my laptop in 20 minutes. Why does it take you 2 months? Well, because we're doing it on 1,200 machines, and we have to go write the scripting. It's my word. If we actually had people running around and just installing everything onesie and twosie, you'd have a Wild West inconsistent mess. And so, yeah, and you're right. Some people would cheer for that. Hey, just give me the admin access. I'll do it. Yep. Yes, you're not alone, sir. You're not alone. Yes, Mark. How's the Puppet migration? It's coming along. We're actually doing as part. So when we're going to Red Hat 7, we're actually trying to deploy off satellite, and that includes the Puppet modules. So we're writing some of our stuff, converting it to Puppet modules. It's coming along. It's more a matter of, oh, thank you, 2 minutes. It's more a matter of just finding the time to get through and port some of the stuff, squashing the bugs. It's definitely interesting since we're not we were running actual open source Catello, so we are then the admins, full admins of the satellite-ish thing, but we decided to go to the Red Hat satellite provided by Central IT. And that's interesting because we don't have full admin rights, so we're always going and bugging the Linux admin over there. Hey, can you give us we can't seem to do X or Y. We need to get the right permissions, and we're trying to figure out what are the actual name of the permissions we need. We have time for one final question. Are there demands for other distros? Yes. The most common request is for Ubuntu. And I'm not opposed to Ubuntu. I run it at home. But the issue is that the engineering application vendors will not support anything but an enterprise Linux distro. And in fact, they're often behind, like, wait, you're running Red Hat 7? I'm sorry, we only support Red Hat 6. I mean, that's the kind of thing that we face, so that's it. And thank you very much.
Citrix Zen Server gives you everything you need to integrate, manage, and automate a virtual data center, all on an enterprise-class, cloud-proven virtual platform, and at a third of the cost of other solutions. But why even bother with virtualizing your server infrastructure in the first place? Well, let's say you have a traditional one server to one application architecture, but you're running out of resources and performance is suffering. Once you order new server hardware, you'll wait for delivery, configure it, install your business application, stage and test the server, and finally, add it to your production farm. If you've been through this process before, you know it can take weeks or even months. You also know it's a manually intensive process that will burden your team every time you outgrow your current setup. With a virtual server solution, you could accomplish all of that in less than half a day. Server virtualization software separates the OS and application from the underlying server hardware. And with multiple virtual machines on a single server, you can use each of them to run different OSs and applications. This makes it possible to move your virtual machines from one piece of hardware to another whenever you want, to maximize utilization, simplify maintenance, or recover from a hardware failure, and without slowing down your applications or users. Clearly, server virtualization provides big benefits, and Citrix Zen Server provides even more. Since it's built on an open platform, Zen Server plays well with your existing hardware, storage systems, and IT management software, as well as with the industry's leading cloud service providers. Best of all, you can get started by downloading a fully functional, production-ready version of Zen Server for free. After a 10-minute installation process, you'll see how easy it is to start virtualizing your workloads and automating your IT management processes. And when you're ready for a richer set of management tools, just upgrade to one of the premium editions of Zen Server. So whether you're interested in virtualizing servers for the first time, expanding your server virtualization footprint, or moving server workloads to the cloud, download and install Zen Server today and see how it can help you simplify your IT environment. Citrix Zen Server. Do more. Don't spend more.
Your customers